the next principle of measurement uncertainty estimation is that all relevant uncertainty sources have to be considered, and those that are important have to be taken into account. We have already touched the concept of uncertainty source, but let us now go a little bit deeper into it. And let us do that again on the example of this orange, pesticide determination orange. And let us again look at the steps that are in chemical analysis, and let us try to think what types of uncertainty or what kinds of uncertainty sources can be involved in different steps. And let us now go back to the place where the sample was taken. And we start with the first operation that is inherent in chemical analysis, and this is sampling. When sample is taken, then the sample is brought to the laboratory, and depending on its nature, it is usually reduced in size because initial samples can be very large. And then different operations are done, and as we've already seen in the case of orange, we then usually need to homogenize. Then usually some extraction. Then purification and concentration of the extract. And then when we finally have the extract solution that can be introduced into the analytical device, into the analytical instrument, we really can carry out the instrumental analysis. There's one more important step that is not evident here now. The large majority of those analytical instruments need calibration with the analyte, and this also needs to be done. Finally, we do data treatment and get the result. This could be, in a nutshell, the main operations that are involved in pesticide determination in orange. It's important to note that chemical analysis is a very diverse range of activities, so that not always these same steps apply. Some can be omitted and some new steps can be there. But as an example, it pretty well summarizes the general situation in chemical analysis. Let us now look at the potential uncertainty sources that are involved in these steps. if we start from sampling, then sampling does have uncertainty due to non-representativeness of the sample. Meaning, the pesticide content in the particular oranges that we took from the overall lot can be somewhat different than the average concentration in the other oranges in that lot. And in order to avoid that, people usually take samples in such a way that they take sample from many parts of the whole lot and then average in the laboratory. This is for assuring that the sample is as representative as possible. It is also important to note in the case of sampling that this uncertainty source only will be taken into account if we present our result for the whole bulk, the whole lot of the analysis object. If we present our result only for the sample, then the uncertainty source due to non-representativeness of the sample is not taken into account. Let us now look at the next steps. These next steps can jointly be called sample preparation. And sample preparation has numerous uncertainty sources. First of all, the analyte can, in different ways, be lost, so that during all these operations, some part of the analyte is lost, and finally, less analyte arrives into the instrument than was actually present in the sample. And those losses can be due to the following. Incomplete extraction, losses during purification or concentration, some analytes are prone to decomposition. These losses during purification can also be, for example, caused by adsorption on surfaces. In some cases, analytes can be volatile, and then there can be volatilization. Pesticides are almost never volatile, but other analytes can be. Now, all these effects that I have mentioned here lead to decrease of the measurement result. But there are effects that also can lead to increase of the analysis result. And in this particular section, this can be caused by contamination. It is generally accepted and recognized that sample preparation is usually the most important part of chemical analysis from the point of view of a measurement uncertainty. meaning there are more uncertainty sources and they are usually more influential in this sample preparation part than in any others, except perhaps sampling. Sampling uncertainty also can be very, very high. Now, let's look further. In this instrumental analysis part, we have different instrument-related uncertainty sources, such as instrument, noise, drift, etc. But on the other hand, very importantly, in this part also there's the incomplete selectivity source. This uncertainty source means that instrument is also influenced by some other compound besides the analyte. As is generally known in analytical chemistry, selectivity is one of the most important things. If we determine some concrete pesticides in orange, then we are interested that the signals that we get from the instrument really do correspond to these concrete pesticides and not to other compounds that perhaps were present in orange. But almost always those other compounds have some small influence on the signal, thereby causing uncertainty. And very often those influences are positive in the sense that they increase the signal so that we get a seemingly higher result. This kind of uncertainty source, and also many of those that are listed here, are especially problematic and especially serious if we determine low levels of analytes. And pesticide analysis certainly is a low-level analysis, or as sometimes people say, trace analysis. Now, calibration. It is first of all influenced by all instrumental sources. And on the other hand, it is also influenced by the concentration and purity of the calibration materials. And data treatment can also have its uncertainties. It can sometimes be not so easy to extract the concrete information, the concrete signal from the data that is obtained by the instrument. So certain data treatment uncertainties are also present. Such as, for example, integration of chromatographic peaks. If you look now at this list, something is missing. And we see that completely missing are the uncertainty sources due to pipettes, volumetric flasks, weighing, etc. But they also, of course, need to be considered. The reason why they are not directly introduced here is that they occur in many places. So whenever sample preparation is done, it usually involves some weighing. After sample size is reduced, it's weighed, and weighing uncertainty is there. Throughout these operations, some solutions are used, and oftentimes volumes are measured. And of course, calibration solutions are made usually by weighing and volumetric operations. So that both weighing and volumetric uncertainty sources we can also put here as general uncertainty sources that influence several parts here. Now, what should an analytical chemist do with these uncertainty sources? There are two main things that we have to consider and we have to do with them. First of all, and very importantly, this whole procedure and the way it's executed has to be done in such a way as to minimize all of these uncertainty sources. It is good if they can be eliminated altogether, but if they cannot be eliminated, making them as small as possible is also useful. And on the other hand, every care must be taken to find out which of them are important uncertainty sources. And those that are important have to be quantified. And again, care has to be taken that they are quantified in a rigorous and logical manner.